All right, good morning. So, this lesson we are going to go over several vocab words and we're going to be doing some long division. So, this is grade 7, lesson 1 2, understanding rational numbers. So, for example, 1, it says divide to convert the rational number 52 over 80 to a terminating decimal. So a terminating decimal is our first vocab word. It's a decimal that ends in 0. So that means essentially it comes to an end. So like 3.5 is terminating because it could be written as 3.50 or 3.5000. So a terminating decimal means it terminates, it ends. Okay, so it doesn't go on forever and ever unless there's zeros at the end. It does not, it just stops. So there's two definitions to a rational number. It has to either terminate, which means it ends, or it could be a repeating number or repeating decimal, like 4.33333333. That is a rational number because the 3 keeps repeating. So it either has to stop or it has to repeat. So we're going to go through this more on question 3. So we have to do some long division, which I'm going to try to do as neatly as possible. So we are going to start with, so just a reminder, our numerator goes inside our house. And by house, I mean my little shape that I'm drawing right now. My numerator goes inside my house, that's 52. And my denominator goes outside my house, which is 80. So because this fraction is less than 1 whole, that means 80 does not go into 52. It's too big, so I'm going to put a 0 up here because 80 goes into 52 0 times. So in the case that this happens, now we must add a decimal point after 52 and keep going to see if we can get to a terminating decimal or a repeating decimal, or to see if it goes on forever and doesn't either. So now if I put the decimal point here, I have to put it at the top as well. So I'm going to put a decimal point, line up the decimal point. So now I have to figure out how many times does 80 go into 520. So 80 goes into 520 6 times. So 80 times 6, I'm going to do this out loud, kind of, these calculations. But of course, you can use a calculator. You can show work on the side of your paper. So 80 times 6, I know, is 480. So 80 times 6 is 480. And then I'm going to subtract these two, 520 minus 480. Okay, I know that is 40. Okay, moving on. I do not have a remainder of 0, so I must keep going. So I'm going to put another 0 at the end of my original number, or my original numerator, and I'm going to bring that 0 down until I get a repeating number or a terminating number or a number that doesn't stop or end. So 80 goes into 500. Ding, ding, ding. Perfect. 80 goes into 400. I know 5 times. 80 times 5 is 400. And 400 minus 400 is 0. This is exactly what I wanted, a remainder of 0. And that means I'm done. So my answer, I will rewrite it a little nicer out here. That means my final answer is 52 over 80 is the same as 0.65 or 65 hundredths. So you could stop once you get a remainder of 0. This is what a terminating decimal is because it stops or it ends, and also it's rational because it's terminating, it ends. So this is considered a rational number. Okay, moving on to number 2. Similar steps here. A class votes on whether to change their school mascot. How can you express the number of mascots in favor of how can you express the number of students in favor of a new mascot in decimal form? So 5 kids want a new mascot, which isn't very high. It's less than half, we know. So we're going to do long division, same as before. So I am going to put my house, and I'm going to put my numerator on the inside, and I'm going to put my denominator. Nope, sorry, let's undo that. Sorry, we're going to erase this so there's no hook at the end. Let's make it a little longer. Okay. So I'm going to put my 5 here, and I'm going to put my 18 here. We should all know that 18 does not go into 5. So I'm going to put a 0 up here, and I'm going to start my decimal point. 18, however, here we go. Let's put my decimal point down here and above the house. Trying to do it neatly. Okay. So now, and don't forget to put your 0 here. So 18 goes into 50 it goes into it twice. So 18 goes into 50 twice. So 18 times 2 is 36. Now we subtract 50 minus 36. That's 14. I do not have a repeating number yet at the top, or I don't have terminating, so I must keep going. So now let's change colors. Let's put another 0, and let's drag that 0 down. So 18 goes into 140 7 times. So 18 times 7 gets us close to 140, but not exactly at 140. So it gives us 126. So 140 minus 126, okay, that's 14 again. So, okay, let's keep going. We'll go at least one more. So we do not have what we want, so I'm going to bring down another 0 to the bottom. So 18 goes into 140 7 times again. 126, 18 times 7 is 126, and we get 14. So now I've gotten 14 3 consecutive times. So that means I'm literally going to keep getting 14, then it's not going to stop. So that means I must stop, because otherwise you'll never end. So our answer is 0.27, and I'm going to put this bar on top of my 7. That means that 7 repeats on and on and on. So if you typed it into a calculator, or if you kept going, you would keep getting 0.27777, and it wouldn't stop. So I'm going to put a bar only over the 7 because the 2 does not repeat, but the 7 repeats. And yes, this is considered rational because it follows one of the 2 steps. It either has to terminate, which means stop, or it has to repeat forever. And the 7s repeat forever. So yes, this is rational, and it's considered a repeating decimal. So this is my answer. Last but not least, example 3. So I put the answers on the page for this one, but I'm going to explain them. So explain whether each of the following is a rational number. So let's all look at A. A says negative 6.382. Well, that doesn't go on forever, and it actually stops. So it could go on forever if it repeated, or it could just stop. This is a terminating decimal because it stops. It doesn't have dots next to it. This just stops. So this decimal terminates. So I'm going to highlight this. This decimal terminates. So yes, this is a rational number. Yes, it is. Okay, let's look at B. B does not terminate. So I'm going to circle B so we can all look at the same place. So B does not terminate. That means, I know it doesn't terminate because of the line right there, that repeating bar. But that means this decimal is essentially 1.539981818181. So because the 8 and the 1 never stop, they repeat infinitely, this is also, yes, it's a rational number because it repeats. So even though it goes on forever, it does repeat. So this is rational. Last but not least, let's look at C. It says 0.43524982 ... That ... means a bunch of numbers are coming after, and I don't see any signal that there's repeating going on. So because there's no repeating and this goes on forever, that means C, as it states, is not rational because it doesn't repeat and it doesn't end. It's actually known as irrational, and I think of like irrational people as like a crazy type of person. They talk forever, they go on forever, they don't repeat, they just say lots and lots of things. This decimal is just going on forever, or will go on forever, and it doesn't repeat. It's just a bunch of random numbers put together. So that is not rational.